We have a graph which represents our relation between our spaces here. And this is a tree that I talked about yesterday, that it shows the routes between the spaces. For example, if I want to go from a space 0 to a space 4, this selected tree show me the route that I should pass. And you can check it out when if you connecting the panel to it. The thing you should do is just to checking out the tree branch 4, which represent the space 4, and checking the routes in there. It's a start from space 0 because your start index is 0, and then it shows you that you have to go to space 1, and then you can reach the space 4. So it's obvious by now. So what this component do for us? It's much more in detail for all the passes. So you can connecting a graph chart to it, considering the size for it. So space name is not really important. The value that it gets is a graph chart. It can representing any value for you in the graph, in a linear graph chart. But in this case, we are going to representing the space integration or space cost. So I connecting the value here. So you can see if I want to go in any spaces from a space 0, it shows me that how many steps I should take. For example, if I want to go to step to space 11, I need to take 3 steps to reach these spaces from space 0. If I want to go to space 5, I need to take 5 steps to reach this space. This is just some kind of graph that representing the number of steps that should be taken to reaching the spaces from the start zone. Is it okay?
Okay. Yeah, thank you very much. It's obvious now.
No, okay. So, any other question? Okay. So I think we can start our 2D program. And I want to ask Farishta to start the lecture, and then we are going to do some new stuff together today and enjoy today together.
Thank you. This is the design flowchart for our research. As you see, we have steps to take before the design, the final plan will be generated. The first step would be the user inputs, as we told yesterday in the first flowchart of design process, that we can add some input from users. And in the next steps, the analysis would take place, and then we start to generate configurations, spatial configurations, and then we can check it, make it more specific to our desires, maybe control it, and at the end, the plan would be generated. And now we want to see how a Termite-Nest can do this for us. I will show some slides to show the power of Termite-Nest and how it works. And after that, we will check it together in Grasshopper platform, I mean. Okay, it can be divided into these 4 parts, and also we have other parts that we will speak about. The first part we have here, which is a CSV reader. We have the inputs from user, that is the knowledge source. Maybe we have as we exercised yesterday, we had a table, an Excel table that was the CSV file, and we had the name of the spaces, their area, and most importantly, the connectivity pattern between spaces. That's very important for us in the first steps. And after that, in this part, which is the design requirements, can be interpreted to machine. We show them by indexes, their names, area, and as I told, the relative, the interrelations or the connectivity pattern. And in the next step or the second part, we try to make a graph of relations and also space syntax, which we spoke about yesterday completely. So in this part, we are trying to interpret our data, our input data, which was the CSV file, to a machine and understand these relations. The next step would be the spatial graph, which we tried yesterday, and we will do it again today. In this part, we define the boundary which we will go to make our generation and make our plan inside. And also we can control how how this configuration can be placed in our boundary. And also we can have some evaluations or some controls and changes on this spatial configuration. And at the end, we can, this also shows how the spatial graph and the space syntax that we have ordered can be set to different layouts. That is, and it happens very quick. So you can just check or change the boundary, and the configuration can be happen on different boundaries. And as we told, most of the automation techniques for design process has one inefficiency, and that would be the lack of enough interaction with users or designers. And this is where Termite-Nest takes steps to and tries to solve this problem by make users or architects have a strong interaction with this platform in making form generations and spatial design. By having the ability to control the spatial graph in using different controllers. So this interaction is something that Termite-Nest brings about. And it does this interaction in two parts. First is what we exercised yesterday, that we could have 2 points around, or also it can be on the boundary curve. So we have 2 points, and we will define these points as one of them as our start index and the other as our end point for our graph. And we can move these control points to check different graphs. You see here in this movie that we have these points at the first level, and then we start to move the points, and you see the graph, the spatial graph changes its configuration based on being near to these points. So we will also check it in Grasshopper to make it more clear. Okay, and as you see here, we can check what index the first point and second and the end point would work with. Okay. And this is the reset button, which is very important. Sometimes you need to use it to see the differences when you change something in your spatial graph. And this part, you can control it more with 2 or 1 more points that you define for it. And there is a threshold that you can change the strength of the point, the control point, and how it can push or pull your graph into itself. And also, so you can use a combination of these factors. You can use 3 or 4 control points to check what you want to have for your spatial configuration. And the process can be set to other boundaries, as you see. So you are not forced to just design plans that are cubic, or just work in quadrilateral planes. You can work in free forms. So in every boundary, you have the ability to check your spatial graph using these techniques. As you see, when you want to add the new point, you have to use this collaboration as your reset input. Okay. And let's continue. The last step, which is the evaluation and finding the output result, would be this part where we use diagrams and we generate our final plan based on what we have ordered in our spatial graph. And you can make these plans that have been applied to different boundaries. As you see here, we showed you the spatial graph part, and then they can apply to the plan generation. Again, here you can see the plan generation on different boundaries. That is the next step after a spatial configuration. These are bubble diagrams that you exercised yesterday, and also the plan generation, which is the output. And as I told, it's so quick, you can just set a new boundary and all the process can be applied to this new boundary. Yes, so this was a general introduction of Termite-Nest and its abilities. And now we are going to start it together, write it in Grasshopper. As I told, some of you asked me to make this process step by step, because yesterday we worked on sample files which were written before, but now we can exercise it together, try to design the whole process together. So please everyone, start your Grasshopper and your Rhino, and all of you have Rhino-Nest, yes? Okay, please open your files. You have Termite-Nest, and you have these components over here. I explained that the first component is CSV Reader, which I told it is about adding the design requirements to the design process. You have these components here for graph making. You have a graph maker, a space syntax, and a spatial graph. So it's all about drawing the graphs. And the other part is drawing the outputs, which is the bubble diagram you have here, and also the layout or the final plan generation. And you have here this graph chart, which Mohammed explained at the first of this session. One of you asked a question about it. It's about analyzing the graph and the relationship between the spaces. And also we have this controller for controlling the spatial graph, which we will speak about it today. So we want to start step by step how to write this design process, how to design the whole plan generation together using Termite-Nest. And before we start, I just want to say that this Termite-Nest, this is a beta version, which is developed by Mohammed Hassan Saleh Tabari within Half Panel Group. And we will be glad to have your feedbacks and to work on it more. Mohammed will consider your feedbacks, and in the next release or next versions, he will consider to make it more powerful. So thanks you all for having this collaboration with us. So first, we start with CSV Reader. And as you know, we start with Boolean toggle, and we take it as an input. You can enter the Excel file or the CSV file to this component. And in lots of steps, you have a README output that you can see what you have and what is the output of this component. And you have also the department list. We can see what you have in your CSV file, the connection ID, that is the connectivity between these spaces, and also you have the area list. As one of you asked a question, I think Patrick, it was your question. You said that you had a boundary and you had an error. Sometimes it's because the area that you have set for your boundary is shorter than what you have for your areas. So this plan generation cannot be generated on this boundary. You should check this area and their mass addition, and check that your new boundary is larger than this, or is at least equal to it. Okay, so after you insert this data from user, what you should do is you can use this graph bar, and you use the graph maker. So please do it with me. I hope you are all following step by step what I am doing. The department list should be connected to all departments, and you have connection ID, and it asks you for a graph boundary. So using a curve component, you can add or set curve from your Rhino screen. And also it asks you about a start point index. What is about is that which spaces would you like to start your graph from, which Mohammed explained yesterday about it, and also about when he wanted to show the graph component. As you see, when you start from different indexes, your relation graph will change. And now we are going to do it together. So I'm going to check how many spaces do I have. Or maybe this one. And I see I have 9 spaces. So I make a slider from 0 to 8. And I can check it. And the text height is for the index numbers. Maybe I can make it on 1.5. Yes, or maybe more than this. And you can see here that it starts the graph relations from space 0. And let's change it to space 2. Oh, okay, we can see it here, but it has the effect on other steps. Let's, yes.
I want to talk about the space index. If you connecting the panel to selected tree, you can see the changes. What exactly this component do is creating a graph based on your inputted relation, and also creating and using the Dijkstra algorithm to calculating the best route to reaching spaces from your inputted index as the start point. And what it do is it calculate and store all the routes as a data tree for you. And while you change the start index, you can reach the whole routes to that lead you from your started index to other spaces. And that's exactly what this graph do. It's not just creating a graph, it's also calculating the route for you. I show you that I will show you how you can use it to generating the place integration and analyzing the corridor, for example, in some plans, to understanding the most peaked place with higher occupancy in your plan. This is exactly where you can, this is exactly a useful component if you want to analyzing the relation graphs in a plan. So I will go to do some examples at the end of today, much more about it.
Yes, exactly. Mohammed explained about it yesterday, that you can also check these relations and which path would be the most efficient yesterday on some plans that we also exercised together. And so thank you for explanation. And after that, we have space syntax. And what you should do with the space syntax is connecting the selected tree, which is the output of graph network, to these two first places, node index tree and node topology. And it asks you for a space syntax boundary. You can again set a boundary to it. And the area list is here. We have it on the first component. So we read the area list from the CSV file and add it to this space syntax. And we again have this start point index, which is, we can use it again. The first, the same index that we used for our graph generation, graph relation, and we have this text height, and use it again, or maybe more. This is the space syntax that is generated based on this first graph. And if we change this index, we can see different configurations for our space syntax. So the level of the paths you should take or steps you should take from one place to other can change using a different start point for your graph. Okay, let's set it for 0. The first step, the first place, which is our main entrance. Okay, and after this part, we have a special graph. So using this relation graph and the space syntax related to it, we can start generating our spatial configuration. As I told, it can be set in different boundaries, so we can also check it together. We have this boundary for our spatial graph. I'm setting for the first step this boundary, and then we can change it. We have the topology, point topology, and we connect it to our point topology of a spatial graph. We have our target, and also we use a button to reset the spatial graph. And now this is two controllers that I told you and showed videos about, and you also checked it yesterday, that you can have 2 points, and by moving these points you can change your graph. And how it works, it is based on your spaces. So I can just set these 2 points as my start and end points, and see what it happens. So we have these points, and we can define which spaces these points would relate to. So maybe I will define the first step. I want the 0 or main entrance to work with this point. And I want my maybe which living room, or maybe bedroom 2. I want index 4 to work with this point, which is the end point. And again, we have the department areas that we use this component for. And iteration step, which is also a critical input. Sometimes when it is on 0, it doesn't, not sometimes, always. If it's on 0, it doesn't work properly, but if you change it to 1, 2, or more, you can see that the configuration changes. And you have seed that can make different output for you. Okay, now let's reset it. Okay, this boundary is very big for this area. We can check it here. Yes, we can also do this. Yes, and also let's check the area. We can use mass addition of this area list that we have in here. So it's 2010, 210, or 2100. And now let's check it with what we have for our boundary. This is our boundary. This is very big, so we can make it a bit shorter. Okay. And now let's check the iteration step. It can change.
I just wanna talking about the iteration step and the point that is behind it. The
Yes.
iteration steps in this release, we just setting three main iteration steps, and it's really important and really affected by the space size and the scale of the building you're trying to design. In the building with a small size, for example, like house building or apartment with 8 to 10 or 12 uh, uh, spaces, iteration one can do your exact do exact can do exactly what you want and create the relation and separating the spaces correctly. Um, as I talked yesterday, the methodology of the spatial graph is to generating random points inside the boundary and trying to pack them in a way that they reach the relation, the best relation that comes from the space syntax, and also locating in a real scale inside the boundary. And the iteration step do this for you. Uh, I just setting the iteration step in a discrete means here. So if you have a problem with it, and if you change it in your desired plan, and you can reach errors, you can please please tell me what's the problem. So and I'm still working in this part and want to know exactly how other user can integrate with it and how it's work in different scales of the apartment. From the experiences that we have, it works for us, but I know it sometimes maybe cause problems. This is a part that I want to have your idea and your feedbacks to make it much more better. Um, it's okay. Thank you.
Okay, thank you. And so we were speaking about these 2 points that work as a controller for our indexes that we set for them. This is the main entrance, and this is the bedroom 2. So by changing their place, we can see that our configuration changes. Or also we can change the index that these points are related to. Maybe we can change it to 5, 6, and you can see the configuration changes.
You can show the index number of points to make it clear, much more clear.
Yes. This point. works with 0. So if I change it, you can see that a graph and the 0 index changes with it. And this is working with index 5. Maybe I can change it to maybe 6, for example. It tries to shape the spatial graph in order to make these points near these indexes. And this is one step of controlling the spatial graph. We can also add more controllers to it, and I will speak about it also. But before adding new controllers, let's check this configuration, what happens in different boundaries. So we checked it in this square. So let's check it in a circle, for example. And you see the packing of these spaces, or a spatial graph of packing the locations of these spaces changes respectively. And again, you can use these points and reset it to see the results. Okay, so maybe check it on one other boundary and then continuing our work. Okay. This is when it happens that it puts some of the spaces out of the boundary. And the problem is that this boundary is very small for this area. We can see it here. It's 667, which our spaces are larger than this. So we can make it bigger. And now it works. So you can check these components when applying changes to your spatial graph. And let's come back to our square. Okay, I want to add more control on this spatial graph. And to do this, I'm using this location controller, which we have in here. And what this controller does is just as the icon shows, it's like a controller for gaming. And so you can add points, and you can control the places of these points and which indexes they're working with. So it's similar to what we have in here, but it has more strengths, and I will show you. Let's just work first with one point, and it has the ability to work with 2 points. I will set this point here, and something, I think my internet is unstable. Can you hear me?
Yeah, it's okay.
Okay. Yes. One thing that is important in setting the index for this new point is that you should consider this point, the index, not be the same as these 2 indexes that we had set before. So if you set the same index, for example, let's do what we shouldn't do, we would have error at the end. So I'm just completing and then showing you how it shows the error. And the usual is how this point will have a strength or for pushing our graph to itself. So we can make, for example, 1300. And how it can be connected to our spatial graph is to change this reset bottom and change it together. So we use a AND gate AND. And we connect these two inputs and connect it to our reset. And as I told you, it shows an error because the index of this new point is the same as these 2 points, one of these points. So you should change it, maybe to 5, so the error will goes away. Any questions until here? If you have any questions, please let me know, because I want to continue and I want to get sure that you're all following step by step what I'm going. Okay. And now let's check this threshold. As you see, it shows how much to have impact on this index that we have introduced for it. So let's check it, change it to maybe 4. You see? And you can make it more effective to shape what you really want for your spatial graph by using 2 points. We are now using 3 controller, and now let's add 1 more and have 4 control points. Okay, maybe set one of them in here. And also define an index for this one, maybe 3. And now we have it. And also we can have 2 thresholds. Maybe make it more strong than this one, or the impact is more than this one. One of them on this number and the other would be on maybe 100. You see, and let's change the places to see. As you see, this point is having more impact on 4, index 4, than this one, because the threshold is less than this number. So we made our spatial graph. Maybe we can a little make it smaller. So press the reset. Sometimes you need to do it. And the last step would be drawing the bubble diagrams and the final layout. So let's start with bubble diagram. You need to set the same boundary as you set for your spatial graph. So just connect this boundary to the draw boundary, and you have the points you have in here, points from spatial graph. You have area list, which you again use the first component or the Csv Reader for area. And you have BIOS. BIOS is something that you can change your sizes and the area of spaces based on it. I will use example. And I should again set the number of my gem pools based on my spaces, and I have 9 spaces, so I change it to 9, and usually we make it from 0 to 2. And is starting to place our bubble diagrams. Let's check our iteration step. Put it on 2. And we have enough space for these places. But the bubble diagrams now are less than what we should have. And so we can work with this BIOS to place different spaces, because this is a packing methodology, and it increases the area of one space. So maybe one of the spaces are omitted because of this work. And we can change it to see our new spaces. Mohammed, if you want to explain about this component, you can join us.
About the BIOS, as I said yesterday, you use the area input entry in your CSV file to generating the space location based on it, and your and use it in the special configuration. And in the bubble diagram, the methodology is a little different. It tries to circling and to showing the spaces, the needed spaces for each location with a circle, and then packing them together and creating a diagram shaped like the convex to representing, and this convex is also using for the space relation in the output geometry creation. For example, if two spaces have interaction, it has if two spaces have the same edge between them to get between each other, it means that they are in adjacent together and has a relation together based on the metric relation that we talked about, and we told that it's really important in our algorithm, because it's really affect the final shape, the metric that we use in our relation definition. We use the metric as the same door or the direct relation between spaces as a relation between a space when we filling the CSV file, and then the whole process are going based on the relationship metric we used. So here the circles packet to show the spaces area for each specific location are competing together to reaching the most to reaching the accurate area for the desired space. So maybe some of them are missed the accurate size. So the bias here is defined to aid you to controlling the area for them. And this is a repetitive process which is really related to the spatial configuration and the spatial graph. And they are effect on each other. So maybe sometimes the spatial for separation, which is come from the spatial graph, may not absolutely reaching the accurate space for the desired locations. It's what happened in our traditionally way of the architectural design process, and the way we think that the spaces adjacent together in a boundary is not 100% necessary reaching the best area for us, and it also have some errors like it within itself. In this algorithm also have this error within itself, and the way that it's trying to correct itself is the organization, and in a is to organizing itself with the BIOS threshold, and changing the location based on reaching the area for itself. So in this basic example, you are being familiar with it, and we are going to talk about it more specifically and more deeper in the next sample files, and trying to do much more example together to become more familiar with it.
Okay, thank you. So we have this bubble diagram out of, I think we have questions in chat.
No,
But I can't see.
Participants only admitted. Yeah, it's okay.
Okay, because I can't see the chat bar now.
Okay.
Okay. And the last step is generating our layouts. So we use this component from here, layout generator, and we can use the same boundary because we have set our spatial graph in this boundary. So we have our plan to be generated in this boundary, and we connect the boundary for a spatial graph to our draw boundary here. We have a run input. We use a Boolean toggle. It asks us about bubbles, so we use it. We have center points, which would be connected to point here. And there's a distance that traces our plane as our plan with a distance from this spatial graph. So maybe make it on 23. There is a threshold that usually should be on 1.5. And there is department names, which comes from the first component. Here we had the department list. Text height for spaces, maybe we can use 2 to write the name of spaces on each space. And now let's make it true. Okay, maybe put it on 28. Okay. Now we have this generation of plan. And as you see, we can change our controllers to find new plan generations. So it's interactive. The user can change it. And by pressing reset, you can have its result. Is it changing?
Sometimes it's working a way to not going to show a necessary point. Oh, it's fine. I will talk about it. It's okay.
One more. Okay. And okay, you want to speak about it now?
You talked about, you showed the whole process, and I just wanted to talk about the threshold parameter in here. This is another part which is important to generating spaces, and it also depends on the project. The methodology of the threshold is in a way that it's trying to turning the free-form convex hull into the geometry shape. So it used the voxel-based design process, and so I don't know how much you are familiar with this methodology. It just act like as a pixels and trying to understanding the pixels that can combining the geometry shape that is also in an area that is familiar with the convex free form. It tries to creating the geometry in an organized way from the pixels that is also equally in size of the convex hull, which is free form and represented to you. So it makes the threshold here is aided to find reaching the best resolution for the voxel or the pixel that it works with. I will explain a little deeper about it today, and to make it clear for you to have a better interaction with it and understanding how you can change it to reaching your desires. And it's really help you to packing your shape in a more organized way, and it depends on the number of the spaces, the area of the spaces, and the shape of the spatial formation or configuration. So thanks Freshta for her explanation and the and explanation the process. Uh, if you have any problem, I think you all do the same process with her. So if you don't have any error using the process you do with her, we are going to continue. Or if you have any questions about any component, any parameters, or if you don't reaching the uh, output that it's represented here by yourself, please ask it to know exactly what happens for all of us, and then we are continuing to do some example.
Any questions? If you have any questions, please turn your microphone on and ask it.
I'm gonna wait for someone else.
Okay.
Well,
Who is speaking?
I was trying to make the example that you were working on right now. I'm starting to have a lot of errors in the third component, the one called space syntax component. I have an error that says that there is it's unable to add a circle on the document. From there, I wasn't able to work on it, but I was trying to work with the others, with the other algorithms that you sent us, so I can keep on your rhythm, and I wasn't able to work on it. So maybe if there is a way to check this algorithm or to repeat the process.
Okay. As I told in this step, if your boundary is very small, it shows you some errors. please check the size of the boundary for your space syntax. Is it okay?
Well, I have it like 100 meters by 100 meters right now, so maybe it's enough.
Okay, please, could you please just give me a screen of your
Yeah,
error?
of course. Can I share the screen? Just tell me when you're.
And also maybe it would be from your text height of this component, but we can check it. Please share
Okay.
your screen when we can check together.
Okay, I can share right now. You have to end your
Yes.
screen.
Okay. Now we can share it.
Okay, are you able to see what I'm doing here?
Yes.
Just let me know when you.
Okay. Please, I understand. Okay, it's okay. Please check your text height number and set it to 2 or 3. It's for the space syntax. For the space syntax.
Oh, okay, sorry. So I have to use.
Use the number 2 or 3. So okay, check the bubble.
I'm sorry. Check the what?
Checking the bubble, which showing the error on the top. Okay. So just stretching your boundary in the axis Y, the boundary that you draw the space syntax with it.
Okay, it's the one on the middle.
Stretch it in
to do it?
with dimension. Yeah.
Okay.
No, not a whole. Just stretching your space syntax boundary, and it's okay.
You have too many spaces. Yes.
Okay, this is the one that we were working yesterday. I wanted to try
Okay.
with a big
It sometimes happens when you have so many spaces, and you should have a really stretched boundary for a space syntax to show steps for it.
Okay, so I see. So I have to start to look for the correct size of the boundary.
Yeah.
Yes.
Until it
Now
comes.
it's going to work. Yes.
Yeah, maybe it's going to work.
Okay.
It's too complicated. Maybe it would be better to work on a CSV file with less spaces.
Okay,
Now
I'm gonna work
yes.
with something later. Great.
Okay.
Thank you very much, Rashid and Mohammed.
You're welcome.
So,
Okay, and I just want to add one more item, and then you can continue. Let's see something. One of the questions yesterday was about the differences between the area of this layout and the area that we had in the first part. One method for solving this problem is using genetic algorithms and by using the differences between this area of these new spaces and the area we had in our CSV file. So what we can have here, this is our layout or the spaces that we have. One thing that we can do is using the area and the mass addition of this area. Or also we can not using the mass addition because we want to check the differences between area of each space, okay? So we can do it in two ways. We can just check the whole area of spaces, or we can check the difference between area of each space, which may be more relevant. So we have the area of these new spaces, and we also have we can use a panel to see the area list of spaces at the beginning. And what we can have in here, we can use a subtraction method and subtract these two areas and use an absolute component to make it right. And what we want to have, let's see what we have in here. Now the differences between the area of spaces are as shows here. Okay. And what we want to have, we want these numbers to be least. So we want a method to make these differences be the minimum. What we should do is using Galapagos and putting our fitness on this number, these numbers that we have in here. And for our regional, we can use this bios that we have in here, the gen pool, and these spaces could change their sizes so that we have the most relevant areas. So the plan generation would be the most proper that we ordered. Okay, so we can use it, and it tries to make the areas more similar to what we had in the beginning, and also we can use other factors for our genome. For example, the control points can be very effective on this generation of plan. We can use all these parts to have results on our final plan. Any questions?
Oh, it's fine.
For example, have you ever implemented something that might like, how can I say this? Something that works with the proportion of the spaces. For example, some kind of switch that help you to say this space may have like 4 square meters, but can't be less in one of the dimensions, can be less of 1 meter or 2 meters, for example. Have you ever implemented something like this in some other algorithms that you have made before?
You mean the sizes of the area of the spaces?
Yeah,
have
some kind of restriction of proportions. Yeah.
Yes. I think in this version you cannot have this, but in the next versions, in next releases, this
Okay.
is something that Mohammed is going to work on. Yes.
Okay, it will be great. Thank you.
You're welcome.
Thank you. So,
I just
Any
had
other
one,
questions?
I just had one comment. When you were setting up the location controller, maybe I misheard it, but I thought you said that you put a gate and.
Yes.
To control, shouldn't it be a gate or?
no. Let me just explain it immediately and briefly to show how it works. The output of the controller component is a signal which is true or false. And as you changing the variable or the inputted parameter, it just immediately sends a signal true and false, which read it by the spatial graph component inherently, and it understands to reacting from the signal that comes from the controller point. So the gate and is here because we want to use both of the button, true, false, and the signal together. If you use or, the output of the true, false may not being okay. And when we use gate and, immediately when each of the signals turns true or false, the output change from the true or false, so it can understand to reset automatically. So when you use the gate or, the output not exactly the same with that change immediately. For example, if you use gate or and you have true and false, and if you have false and false, the result may not change to true. So the component look steady in the same position as it has in the past. And gates and help it to change and to understand the changes, and use both of the button true false, and the signals comes from the controller.
It's just that with the gate and the reset button doesn't seem to do anything.
No, it works.
I mean, if you click on it, does it reset? It doesn't seem to reset the position of the points, no?
So, oh, it's okay. Because you have 2 points now, you have true, false, one true. It's because of the, yeah, it's true.
So, I mean, yes.
Yeah, I understand. Yeah, yes, you're right. So we can change it for the 2 points, yeah.
Okay, so when you have more than one point, we can use the gate or, correct?
Yeah, it's okay, it's okay.
Thank you.
So, and also the controller just support 2 points in this version. I just want to explain it. How many points you can adding how many points you want, but unfortunately in this version the controller just support 2 points, and I do this by the purpose. I want to check it out, how's the feedback from the for controller, and with the iteration and relation with initializing in the spatial graph. So I'm working on the other kind of controller points, and I will release it in the next version, which aid you in the new kind of way to using the other relations instead of the anchor point to controlling your graph.
Just a quick question. Are you also considering maybe implementing a threshold for the starting and endpoints? Just to kind of make them,
yeah,
I mean, to be able
for
to
the
control
spatial graph,
the strength.
I'm just not putting this for a special graph because I think it's made really it makes input parameter very large. We have a lots of input parameter by the time. Because of that, I use the default for the special graph, which works on it, and I put some logic for it to consider the relation by its own by the time, based on the size of the spaces and number of spaces. It's kind of the statement that it have inside itself, and decide to choosing the relation, the threshold for the relation by its own, for a start point and end point. But it could be also a threshold for it. I can add it as another component that can control the spatial graph. You, when you, as a user, want to use it, how's for you? You prefer to have the threshold for the start and the start point and end point, or just for the control point is enough?
I mean, I guess that would depend on how many control points you can use. No? If you can use
Yeah.
more than two.
Oh.
It's just that sometimes, I mean, when I'm just trying to control stuff,
Yeah.
I feel that sometimes the start or the end point kind of loses against the control points. But
So,
I haven't, I mean, to be fair, I haven't used it that much yet, so we'll see.
So yeah, I'm working on it in the next version, and for this new kind of interaction, which tackle this difficulty.
Okay. And any other questions?
So I think we are fine with this by now. So we have options. We can do the sample files that we lived yesterday and completed together today. I told you to trying to creating the layout based on the parameter we extracting from the plan sample one. And some of you made it difficult to controlling the points to creating a layout. So I did it in two different methodology, in different two way, and I'm going to show you today how you can do this and how they affect the way you can controlling the points. And also, I just don't remember the other option, so let's just going to do this. Okay. So I will uploading the file for you, and we are going to start it together. So how many of you are trying to do this by your own, to controlling the point and rewriting the plan? And how was the effort?
Maybe you can tell us about your experience. I think two of our participants told that they have worked on this.
Yeah. I think Patrick and Roberto do some efforts.
Anyone else has done this? Maybe Danny?
I haven't got
No?
on it yet. I've been working, sorry.
Okay.
Okay.
Actually, I was wondering also, would you maybe publish some kind of manual or tutorial in a document that we can read to just to check some examples, images, text, or something like that?
Excuse me, you want what exactly you said?
No, I mean, will you publish some kind of text, information text or manual
Yeah.
about the plugin?
Yeah. The user guide some documentation, you mean?
Yes, yes, and user guide.
Yeah, yeah. I will upload it into the food for Rhino to use it as a help. I uploaded the sample file with the Termite-Nest plugin, but I think maybe it's not really describe the whole parameters.
Yeah, it isn't.
Yeah, I will upload the documentation too.
And one thing I should mention is that we had the yesterday session live streamings and the recordings. I sent to your email addresses the links to those YouTube videos. If you want to check, you can do it. And also it is recording today. So every day you can check what we had explained in this session.
Great, I will check. Thank you.
Okay.
So I'm just uploading the file. It's not come yet. I upload it again. And it's not comes again. What's the problem?
Maybe we can send them in emails if you want.
Just try again. So I can't do this. I don't know what is the problem exactly. Why not?
Or also, if everyone has followed what we used, oh, okay, okay.
It's pink. Have everyone opened the files? You all received the file and open it?
Yeah. Well, I don't know. Should we open it already?
Yeah, open the file 01.
Okay.
And we have about 20 minutes until the end of the first part. Maybe we can start it a bit and then put the rest for the next part.
I'm just briefly explaining the definition, and then we're going to we have some rest and come back and explain it clearly. And I will send you a new file. I'm checking the evolutionary process together. I want to check the new way of generation with evolutionary process today. I will send the file to you, and we will do this in the next 3 hours part. So let's just briefly talk about in this 01 file. Let me just open it. Okay, I missed the file. Where is it? Oh, sorry. I think I uploading the wrong CSV file within the plan 01. Let me just check it again. You have my screen? Okay. So the embedded file in the folder 01 is not the correct folder. I'm just wanna you to open the space and graph, the graph and space syntax folder that I sent to you yesterday, plan1 CSV file. because we are going to redrawing this plan together. The CSV I've sent today is not the correct one. Please open the file that I sent to you yesterday. Did you open it?
Yes.
Sorry, what's the name of the file?
Going to the graph and spacing text folder, plan 01, step 1, and the CSV that is embedded in it. So the difference between the file 01 and 02, which are in these samples I sent to you, is based on the level of the abstraction we talked about when we are going to creating the relation, and based on the way that machine or Termite-Nest can do the space location for us. I do this in two ways. First, in the 01.01 file, each spaces even you remember the time I talked about the scale of the spaces, which the living room was the largest scale, and the rooms could be named as the normal scale, and the space or subspaces within the kitchen could be named as a whole space together. If you want to drawing the plan yesterday, so. In this example, exactly, we have some problem with this. If you want to creating a plan, the main entrance, the stair, and WC space are just some spaces which are together in this plan. If you open it, you can see the plan here. So. As you can see, the main entrance and the spaces in here are highly integrated together and packed very closely together, and other departments are located separately. So the Termite-Nest and the controlling the spaces, which is developed in the Termite-Nest to controlling a space, maybe lack if you want to separately controlling these parts to and generating the relation between them. So to tackling this problem, I provided two CSV files, and and you can see the differences between these two definition with these two different CSV relation file, and how it changed the output layout. So I think it would be better if you come back in the next 3 hours and I explain it much more detail and do it from the beginning together and generating these two layouts with two CSV files together.
Yeah, I agree. Because we just have 15 minutes, and maybe it would be great to have a break and then come and work on this new file.
So in the rest minutes, if you have any questions, please ask it, and we are here to answer it.
Okay, we will come back after 2 hours. The 2 hours break will start now, and we will come back then. Okay.
Okay, thank you. See you later.
See you later.
Yes,
Okay,
right.
thank you.